Okay, we finish up section 4.5, solving quadratic equations. And we're going to solve quadratic equations in this section by square roots. Okay, so that's our objective here. And as you look at your essential understandings, I'm more concerned with us looking at this, not worrying about this stuff right here, the perfect square trinomial. We'll take a perfect square trinomial and we'll just factor it like normal. But you can solve an equation that contains a perfect square by finding square roots. The simplest of this type of equation is in the form of ax squared equals c. Now, as you look at that equation here, and you'll notice that something is missing from this equation right here. Okay, you'll notice it doesn't have a b term. Okay, so we can solve a quadratic equation without a b term a little bit easier. Alright, so as we look at this, we figure out how to solve an equation by square root. Okay. First of all, you got to recognize that there's no b term, there's no middle term of the trinomial. Okay, so you'll have an x squared term, there will be no x term, and it's going to either equal something or it could be plus or minus a number equals 0 either way. Okay. When this happens, you'll want to solve for x squared. Okay. You're going to want to solve for x squared. In other words, get x squared by itself on one side of the equation, put everything else on the other side. Now, before, when we did these problems, we said get 0 on one of the sides. Well, if there's only an x squared term and there's no b term, you want to get that by itself. Okay. Then we're going to take the square root of both sides of the equation. Okay. And then we got to simplify radicals so that no perfect squares are left underneath the root. Again, as we look at these equations, you're always going to have two answers. Okay, and these are going to be a little bit different because you're not going to have two things to solve for. Okay, you only have one, which means our answers are going to be a lot of one answer is positive and one answer is negative. Okay, so let's take a look here first at how to simplify a square root, because you're going to have to be able to do this to simplify your equations. Okay. So you get a square root and you get a big number underneath of it, and we got to figure out, okay, is this square root simplified? Well, we have to see if there's any perfect squares that will go into the number underneath the radical. Now, the perfect squares, again, if you look at your multiplication chart, are the numbers that go down the diagonal of the multiplication chart. Okay, so we got to figure out, do any of those numbers down that diagonal go into the number that's underneath the root? If so, we got to break that number down, and you're going to see how I do that. Using that perfect square. So you break the numbers up so we can separate radicals. For example, kind of a review here. If I have the square root of a times b, that's the same thing as saying the square root of a times the square root of b, and then I can take the square root of each single item there. Okay, that goes back to Algebra 1, remembering those power rules and those root rules. Okay. Then finally we're going to simplify that perfect square and then attach the other number that's underneath the radical with it. Okay, so more than likely you're going to be able to simplify one radical and not simplify the other. Okay. All right, let's take a look at some examples here now, and let's go through some roots here. Okay, so as you see here, it says simplify the following radicals. Now, the first thing you want to do here is whatever number you have that is underneath the radical, you want to check to see, hey, is that in that diagonal line on that multiplication chart? Because if it is, then it's a perfect square. Then it should be easy to figure out. Okay. So, as you look at this, 64. Another way I could write this is that this is the square root of 8 to the second power. Well, what happens to the square root and a square? They cancel each other, which you're just left with a simple 8. Okay? Those are the easy ones. 64 is a perfect square. Anytime you have a perfect square, those are the really easy ones. It's the ones that aren't perfect squares, like number 2, where we have the square root of 20. Okay? And it's not a perfect square. Two numbers do not multiply to be 20 that are the same. Okay? So what I have to do is I'm going to look at the chart. Okay, look at your chart, look at your diagonal chart, and see which one of those perfect squares, if any, will go into 20. Well, if you look at the chart, you'll notice that 4 goes into 20 5 times. So I'm going to break down 20 into 4 times 5. Okay, and again, same as before, if I have this, a square root of a times b, I can split them up into two radicals. Okay, so I'm going to split these guys up. The square root of 4 times the square root of 5. And the square root of 4 is 2. I can't take the square root of 5 and get a whole number, and there's no perfect squares that go into it. So this is my final answer, 2 square root of 5. Okay, let's take a look at number 3 now, the square root of 80. As you look at your diagonal chart, what's the biggest one of those perfect squares that will go into it? Well, as we look into 80, it's going to be 16 and 5. Okay, so again, I can separate these two. Square root of 16 times the square root of 5. And the square root of 16 is 4. And again, I can't break down the square root of 5. And there are no perfect squares that go into 5. So I'm done. Okay. Now, I put a bigger number on here for you because you're going to see some bigger numbers every now and then. And it's going to be a little more challenging. Okay. So what's the biggest perfect square that goes into 192? And as you look in your chart, I'm going to do this two ways. Okay. One is you find the biggest number, which happens to be 64 and 3. And the square root of 64 times the square root of 3. So then I got square root of 64, it turns into 8. Square root of 3 I can't break down. Okay. Now I could do this in another way. If you can't figure out what that number would be, you could see, oh hey, 16 goes into 192 12 times. And break this apart. Square root of 16 times the square root of 12. Square root of 16 is 4. But I'm not done, because there's another perfect square underneath 12. What perfect square goes into 12? Well, that's 4. So 4 times the square root of 4 times 3. The square root of 4 is 2, so I end up with 4 times 2. That moves it to the outside, times the square root of 3, which gives me 8 times the square root of 3. Again, either way, you get the same answer. Okay. The best idea on this is to try and find the biggest square root. But if you don't find the biggest one and you find an example like this second one here, where it's a square root of 16 and then 12, you can break down both and then combine your terms. Okay? All right. So we covered square roots now. Now let's take a look at solving quadratic equations by square root. So as you look at this equation, 4x squared plus 10 equals 46. You'll notice again that there is no b term. No b. No x term. There's no x value there. We just have 4x squared plus 10 equals 46. So because there's no middle term, I'm going to go ahead and get x squared by itself. So I'm going to go ahead and subtract 10 from each side. I want to get x squared by itself, so 4x squared equals 36. Divide by 4. Get that x squared term. Get that x squared term by itself, so divide by 4 on each side here. Okay? And I get x squared equals 9. Now that I have the x squared term by itself, I'm going to take the square root of both sides of the equation. Okay? An important note. Anytime you take the square root of both sides, you must make the number both positive and negative. Okay, so you got to make them both positive and negative. So when I take this, the square root of x squared, you'll notice the square term and the square root cancel out. So I'm left with an x. The square root of 9 is 3, and it's got to be both positive and it's got to be both negative. Okay? Or if you wanted to write it out like this, x equals 3 and x equals negative 3. Again, how many answers do we always have on solving quadratics? You always have 2. Okay, this counts as your 2 answers. All right, let's take a look now at example on this set. 3x squared minus 5 equals 25. Again, you don't see a middle term, So we're going to get everything away from that x squared. 3x squared equals 30. Divide by 3. And x squared is 10. Okay. Now I'm going to take the square root of both sides. Is 10 a perfect square? No. Is there any perfect squares that do go into 10 as you look down your diagonal list? And there aren't. So now x is going to equal positive and negative square root of 10. Or, again, x equals the square root of 10. And x equals the opposite of the square root of 10. Negative square root of 10. Again, you still have two answers. Okay? You'll find out that the more you do these are actually somewhat easy. The tough part is the square roots, breaking those down. So, we got 2x squared, and that's going to equal 160 because I'm going to add 5 to both sides. And then I'm going to divide by 2 because, again, I don't have a middle term, so I got to get x squared by itself. So x squared is equal to 80. And so I'm going to take the square root here. So now x is going to equal positive and negative square root of 80. Is there a perfect square that goes into 80? As you look down your diagonal list, you'll notice that 16 does. So this is going to be the square root of 16 times 5, which then becomes the square root of 16 times the square root of 5. Okay? And the square root of 16 becomes 4. So this is x equals positive and negative 4 square root of 5. Again, square root of 5 is not a perfect square, and there are no perfect squares that go into 5. And this is your answer. Okay? Two solutions again, one positive, one negative. All right, here at last two examples. Last two examples here, and let's move this guy up. So solving, again, we're going to solve it by square root. Again, you'll notice in number 4 you don't see a middle term. So we want to get x squared by itself. So we're going to add 49. So 4x squared equals positive 49. We're going to divide by 4, and x squared is 49/4. Do not make them decimals. Okay? And here's the reason why. You'll notice that as you look at this, if I take this square root here, both sides, this is going to be x equals positive and negative square root of 49/4. Well, this is the same thing as saying the square root of 49 over the square root of 4. Which you'll notice the square root of 49. 49 is a perfect square. And the square root of 49 is 7. 4 is a perfect square. Square root of 4 is 2. So we have x equals positive and negative 7/2. Okay, I put number 5 in here just to try and see if we can remember how we need to do this here. As you look at number 5, do we have a middle term? No, we don't. And so we want to solve for x squared. Now, as we look at this, we don't want the x squared term to be negative. So let's go ahead and add it to the other side so that I don't have to deal with a squared term that's negative. So x squared plus 3 is 19. Okay, now, again, I've got an x squared term, no middle term. Got to get it by itself. We're going to subtract 3. So x squared equals 16. Take the square root to get rid of that square. So now this becomes x equals positive and negative. Square root of 16 is a perfect square of 4. Okay? So, solving quadratic equations by square root. Anytime we don't have a middle term, it makes life a little bit easier for us to go ahead and solve. Okay, so tomorrow when we come to class, we're going to work on some more solving by square root and by factoring in both. We're going to put both of them together so we can try and recognize those. Okay, so this ends section 4 or 5, solving by square roots.